Okay, Algebra 1 students, in this video today we're going to be learning what linear systems are, and also we're going to study what characteristics their solutions have. Okay, so we're going to study what linear systems are and what characteristics their solutions have. Now, rest assured, in the very near future we're going to learn how to solve linear systems. Okay, but we're not doing that today. Today we're just going to look at different solutions and their characteristics. Okay, so in your heading I would like you to write down linear systems, lesson 7.1 part 1, and be sure and include today's date. Alright, linear systems, lesson 7.1 part 1, and be sure and include today's date. Okay, and here we go. Like usual, if I go too fast, just pause the video and get caught up on your notes. First, let's start off by looking at what a linear system looks like. Okay, I would like you to not take notes yet, just listen and let me ramble, and then write things down in a second. First of all, the first word in linear system is linear, so obviously we're dealing with linear equations. So this would be a linear equation, because both of your variables have a power of 1 or an exponent of 1. This would be a linear equation. This would be a linear equation. Because both of your y's have a power of 1, here your x has a power of 1. Okay? So a linear system, first of all, has linear equations, and now the word system. Okay? You have a linear system when you have, now here's where I would like you to write notes, and I should have typed this out. You have a linear system when you have two, or please write this down, two or more linear equations. Put together as one problem. Now, all the systems we're going to look at today in lesson 7.1 only have two equations, but it is possible to have more than two linear equations. Okay, so a linear system is when you have two or more linear equations put together as one problem. Alright, so having said that, this could be a linear system. Okay, write this down for an example. If these two equations were given as one problem like this, we'll call it, like in your textbook, it might be problem number 19 or something like that. That's a linear system because you have a linear equation, and they're put together as one problem. Now you're probably saying, what in the world? How would this help me? Well, we're going to look at word problems later, examples later, how these are practical, and we're also going to look at how we solve them later. Okay, you could put this equation here with this equation, and if this was one problem, that would be a linear system. Okay, so a linear system is two or more linear equations put together as one problem. Do you understand? Sorry about that. Do you understand? Okay, and I've given you a couple examples you can write down in your notes if I've gone too fast. Just rewind, pause the video, and write stuff down. Okay, so that's what linear systems look like. Got it? Now let's study the solutions of linear equations. So here we go. First of all, I would like you to, excuse me, I would like you to copy down this problem in your notes, please. If I can locate it here, hold on one second. Please copy this in your notes. This is a linear system. I want you to write down 3x plus 2y equals 4, and negative x plus 3y equals negative 5. Now, here's what I would like you to do. I would like you to, off to the side here, write down this ordered pair. Okay? 2, comma, negative 1. Now, first of all, I'd like you to sit back and just listen and take some really good notes, okay? First of all, understand this is an ordered pair. Got it? Second of all, understand because it's an ordered pair, we know this first number is your what variable? X. And this second number stands for your what variable? Your y variable. You should know that, okay? Now, this is a solution to this system, okay? This is a solution to this system. Are you listening? All of the systems we're going to study for right now in lesson 7.1, and actually throughout chapter 7, all of your answers are going to be an ordered pair. You might want to write that in your notes. All of the linear systems we're going to study in this chapter are going to be ordered pairs. Alright? So get used to that, okay? It's not that difficult to understand. It's not that deep, but just understand that the linear systems we're going to study in this chapter are going to have an ordered pair for their answer. So, having said that, how do I know this is my answer? Well, let me show you. Please take some really good notes, okay? Take your first equation here. Take some good notes on this, please. Take your first equation, and where the x is, right here, I'm going to substitute 2. And where the y is, right here, I'm going to substitute negative 1. Now watch what happens. 3 times 2 is 6. 2 times negative 1 is negative 2. 6 negative 2 is 4. And look at that. I get out a true statement. 6 equals 4. Let's try it over here in this equation. Here's a 2. Substitute in for x. Here's a y. Substitute negative 1 in. And watch what happens. A negative, positive 2. Your signs are different, so it's a negative 2. Positive times a negative is negative. You owe me 2, you owe me 3 more, so you owe me 5. Negative 5 equals what? Negative 5. Look at that, it checks. So, a true solution of a linear system will always satisfy. Now, you don't need to write this down. I'm going to give it to you in a sentence in a second. Just listen to me, okay? A true solution to a linear system will satisfy all of the equations of the system. All of the equations. Not 1, not 2, all of them. If there's 5 equations, then this answer here will satisfy all 5 equations. Do you understand? Okay? So, what I want you to learn today that's so important you learn this is when you have a true solution, the real answer to a linear system, it'll satisfy all the equations. Always. So having said that, would you please write this sentence in your notes? I'm sorry, not that sentence, I apologize. Having studied these types of solutions, please write down this sentence. Write this down. A solution to a linear system must satisfy every equation in the system. The solution must satisfy every equation in the system. It must. Okay, please write that down. I'm going to move on in a second, so pause the video if you need to. A solution to a linear system must satisfy every equation in the system. So, having said that, I want to look at 3 examples. And all that we're going to do, please listen carefully, is we're simply going to test ordered pairs to see if they are truly solutions or not solutions of a linear system. Please write down this first problem, okay? Please copy this down. I want us to decide whether or not this ordered pair is or is not a solution for this linear system. So remember, this is your x value, this is your y value, okay? Let's take your first equation. And by the way, it really doesn't matter which order you go in, okay? You can start with a x is, I'm going to substitute negative 4. Remember, if you're confused, listen, we're not solving anything. We're not graphing anything. We're simply just testing an ordered pair. That's all that we're doing. So where the x is, I will substitute negative 4. You say, well, Mr. Earhart, where'd this come from? I gave it to you. In tonight's homework, I will give you the system. I will give you the ordered pair. And all that you're going to do is test the ordered pair. That's it. Negative 2 times negative 4 plus y. Y is a negative 3 equals negative 1. Now, negative times a negative is a positive 8. Positive negative is a negative 8. Negative 3 is 5. 5 equals negative 1. That's not true. Okay? That's not true. So we can stop right there. Students, would you please listen to me? If a solution must satisfy every equation, then why would I take this ordered pair and test it in the other equation? There's no need if it doesn't satisfy this equation. But let's pretend that this ordered pair does satisfy this equation. It doesn't matter, does it? Because if this ordered pair satisfies this equation but doesn't satisfy this equation, then it's no good. So I do not need to test this ordered pair in this equation. I'm done. I got out a false statement. So my answer would be this ordered pair is not a solution. It's that simple, guys. It's really easy math today. You're just substituting numbers in and testing the ordered pairs. That's all that you're doing. Okay, let's try another example. Please copy this down and let's continue on. Okay, let's start again with my top equation. Really, there's no certain reason I'm doing that. I'm just choosing to start with my top equation. Here's my x value, so I'm going to substitute in for x. Here's my y value, I'm going to substitute in negative 1. 2 times 2 is 4. Positive times the negative is negative 1. 4 minus 1 is 3. So far, this ordered pair checks, we're good, okay? So far, we're good. So in this case, I do need to go ahead and try the next equation because so far it's checked. Now, some students forget to check both equations. They get this out and they stop. They're like, okay, good. It's a solution. We're done. That's not true. You must check it in both equations because sometimes this ordered pair will satisfy one equation and it will not satisfy the other equation. That will definitely happen sometimes. So let's test this ordered pair in my other equation. Negative, and then substitute 2 for x, plus, and then substitute negative 1 for y. There we go. Negative positive is negative 2. Positive negative is negative 1. You owe me 2, you owe me $1, you owe me 3, and look at that, it does check, so we're good. So for your answer for this, you would say 2 negative 1 is a solution, and that's your answer. You tested it, it worked. Really simple, guys. Okay? Now this next problem, you can try it on your own. Pause the video, try it on your own, and then watch to see if you got it right. Or if you don't have the confidence to do that, you can work it with me, okay? Let's first of all, let's check our top equation. Now be careful here. Notice your x's and y's are turned around. And I did that on purpose just to make sure you're paying attention. This is a y, so I substitute my y in 1. Negative x is next. X is a negative 2. There we go. 2 times 1 is 2. Negative negative is positive 2. And positive 2 is 4. So it looks like we're going to have another solution possibly, okay? So the ordered pair does work in the first equation. Now let's see if it works in the second equation. X plus y equals 5. Where the x is, I will substitute negative 2. And where the y is, I will substitute 1. Alright, so I have negative 2, positive 1. $2. You pay off one, you still owe me $1, -1. Look at that. Did not work. Okay? So sometimes the ordered pair will work in one equation, but it will not work in the other equation. Okay? So your answer for this would very simply be not a solution. Really simple math today, guys. Okay, now listen to me. Let me close this video by talking about what we've learned today. I know that the information has been easy. I'm well aware of that. And I'm glad that you guys can have an easy day. I could have very easily covered more material today because today's material is not difficult. But sometimes when the material is so important, it's best to cover that small amount of material and let it really stick in the students' heads. I chose not to cover more material because today's material is really important. It's very, very important you understand what a solution is to a linear system, okay? You need to understand that a solution for a linear system must satisfy all of the equations that are in the system. All of them, okay? You need to be able to check ordered pairs to see if they are truly solutions of all of the equations in the system. That's really